All right. Hi, everybody. We are now in Unit 1B, and we're going to talk about linear relationships. That should be a phrase and a word that we are kind of familiar with. I want to take us back to our last video when we talked about feet, these kind of feet, and inches, and how that is a linear relationship. There's a rate or a ratio of 12 inches for every 1 foot. And we could take that linear relationship and we could say 1 foot has 12 inches, 2 feet has 24 inches, 3 feet has 36 inches. We could say the number of feet is like X and the number of inches is like Y. And in our last video, we graphed that. And what do you know? It came out to be a linear relationship because it had a constant rate of change. And that rate of change was the same as what we saw as the slope on the graph. If we'd made an equation for this linear relationship, it would be y equals 12x because the slope, the rate, aka 12 in this situation, is the number that goes in front of the x, which is something that we've been talking about. The rate of change, aka the slope, goes in front of the x because that's what you're multiplying x by each time in this relationship. This is also a proportional relationship because 0 feet have 0 inches. It goes through 0, 0. Now I want to take a little detour from there, and I want to talk about the Orange County Fair. Any of you guys been to the Orange County Fair? Yeah, lots of fun things to do there. Let's say you go to the fair and it costs $15 just to get in the gates. Then if you want to do anything fun, it costs more money on top of that. And you probably have to buy tickets. And let's say the tickets to go on the rides are $2 each. So you're going to spend $15 plus however many $2 tickets you buy. And the number of tickets you buy could vary. So we could make a formula. We could make an equation for this situation. And we could say the cost of going to the fair is equal to $15 to get in the door plus 2 times however many tickets you buy. Take a second to make sure you understand where that equation comes from. C, the cost, equals 15, the amount to get in the door, plus $2 times however many tickets you buy. This is also a linear relationship, and I can show you why. We can display this relationship in a table by taking the amount of tickets purchased and the cost of going to the fair and saying, well, if I buy 0 tickets, I still spent $15 to get in the door. If I buy 1 ticket, it's 15 plus 2 more, 17. And then each time it's going to be $2 more depending on how many tickets I buy. We can display this in a table or on a graph. And look, a linear relationship exists between those two variables, right? The variables of tickets and total money spent have a linear relationship. Straight line. All right. This linear relationship is a non-proportional linear relationship. Why? Because it doesn't go through the origin. It doesn't go through 0, 0. It's linear, but it's non-proportional relationship. As opposed to the feet and inches relationship we saw before, which was linear and proportional because it went through 0, 0. Okay. If a line does go through the origin, it's proportional. If a line doesn't go through the origin, it's non-proportional. But look at the equations for these. And notice that the one that is proportional had a simpler equation, y equals 12x. The one that had a non-proportional relationship had a little bit more complicated equation. And we could take the 15 plus 2x. Could we write it as 2x plus 15? Same thing. What I want you to notice is I think that the 2 in 2x plus 15 shows up on the graph as the slope, as the rate of change. And I think the 15 also shows up somewhere on the graph as well. Do you see where the 15 shows up on the graph? It shows us how far away from being proportional it is, how far away from the origin. So that's the main idea of this video. I want you to try to investigate this relationship. At Baxter Lanes, it costs $2 to rent bowling shoes and then $3 per game of bowling. Can we make a table of that where 0 games costs a certain amount, 1 game, 2 games, and 3 games cost a certain amount? Pause the video and fill out that table. And then unpause it because I'm going to ask you a couple more questions. All right, the next question I'm going to ask you is, do you think you could make an equation for this relationship? If you can't, that's okay, but try and see if you can figure out what the equation would be for this relationship. Then my other follow-up questions are, you don't have to make a graph, but if we did make a graph, would it be a linear relationship? Would it be a proportional relationship? We'll talk about the answers to these questions tomorrow in class. Thanks for watching. Thanks for listening. See you next time.